and follow the steps, and finally it will give you a recommendation for the fluid package that you should use in this case. Okay, you can try it anytime. Okay, but now I already selected the SRK fluid package, Sauve Reddish Wong. Okay, if you select a fluid package that is not compatible with the components that you selected in the component list, an error message will appear. For example, here all our components that we selected are hydrocarbons, right? We select ethane, propane, normal butane, normal pentane, normal hexane. All of it hydrocarbons. So when you are trying to select a fluid package called OLI electrolyte, you see here there is a fluid package called OLI electrolyte. When I click on it, an error message will appear. Now he is saying that these 5 components are incompatible with this fluid package, because you can see from the name of the fluid package that is suitable for electrolytes only. It's OLI electrolytes, and none of these components are electrolytes, of course. Okay, so he's saying here that the listed components are not available for use in the property package you have selected, OLI electrolyte. Now what's the action? If I click OK, and if I want to use this OLI electrolyte, he will delete the listed components. Okay, because this fluid package is suitable only with electrolytes, not with hydrocarbons. Okay, as we said in the last session, every fluid package is working with some components. Okay, not all the components are suitable and are compatible with this fluid package. Okay, now I will click cancel because I don't want him to delete my components. You see here, now cancel, it will return again to SRK. All I did till now is that I selected already the 5 components from the component database, and I selected the fluid package SRK from the fluid package database. What's the next step? The next step is to go to simulation. From the from the left hand side menu, you will find that there is a button called simulation. So I'll now click on it. I'll click on simulation button. Clicking on simulation button. Now you are in the flow sheet or in the BFD background. You can draw your factory or your plant here. You can draw with help of this palette. This palette containing all the equipment you need. There is a separator and 3-phase separator, and there is heat exchanger, there is expander, there is compressor. You have here all the equipment you need. Okay, now from this palette I'll select a material stream by clicking on the palette, on the stream in the palette, and then clicking anywhere you want to draw. Click here and click anywhere. Now I need to define the composition and the conditions. So I should now double click on the stream, and start defining the data you have. As you see here, there's a lot of data temperature, pressure, molar flow. You need now to just define what the program needs. Just follow the solver. There is a yellow bar on the bottom. Now he's saying that unknown compositions. So, as I told you last session, every time you should follow this solver. This is a guide. You can follow because he will tell you what exactly he wants. I'll not fill all this data. I'll fill just what he asking me to fill. Okay. Now he's saying unknown composition, so I'll go to composition. I'll go to the composition from the left hand side menu. I'll find here that all these components I already selected from the component list. So I'll just write the value of each component fraction. Okay, for the ethane it was 3% and propane 20%, and for normal butane 37, and for normal butane 35, and for normal hexane it's 5%. So for the ethane it will be 0.03. And for the propane it will be 0.2. Normal butane it will be 0.37. And the normal butane it will be 0.35. Normal hexane 0.05. Now the total must be 1. Okay. Now I'll click on OK. You see here the solver updates the message. The solver updates the message, and there is a new message is saying that unknown temperature. So I'll go to conditions, and on the temperature cell I write the temperature. He's saying that it was 225 degrees Fahrenheit. Okay, and for the pressure it was 250 psi. Okay, and the flow rate was 1000 pound mole per hour. So I'll go to the molar flow and write 1000 and select the unit from here, 1 pound mole per hour. After defining all the required data, now he's showing that everything is okay. Okay, now everything is okay. This stream, as we said before, it will enter the 6th tray of the distillation column. So I should select now the distillation column. From the columns, you see here the palette, there is several tabs, so I'll go to the columns. It will not be in common, it will be in columns. Okay, and I'll go to the distillation column. What's the difference between this one and this one and this one? Do you know? What's the difference here between these three? You see, the first one is a package. Distillation tower plus condenser plus reboiler. You see this blue one and this red circle? it indicates that this distillation tower will be like a package containing a condenser and a reboiler. Okay? This one is a reboiled absorber. It's a distillation tower also, but without it containing only a reboiler. So if I select this one, I should build an external condenser for this column. And the upper one, you see, it's a refluxed absorber. Okay, the refluxed absorber. You can see here that there is no reboiler. Usually we select the reboiler, the refluxed absorber, when we want to simulate an atmospheric tower in the refining. Okay. It was in the atmospheric tower. We are injecting a bottom steam instead of the reboiler, so there is no need for reboiler. So if you are simulating an atmospheric tower, the refluxed absorber will be suitable. But now here I want a full package, distillation tower and condenser and reboiler. So I'll select the first one from the left. I'll select the distillation column, okay, containing reboiler and the condenser. So now I'll go inside, double click on the column. Okay. As you see, now I am in page 1 of 5. It's a connections page. This is the first page in each equipment. It's a connections page. Here, what he wants from me, he wants me to just giving him any name to the inlet and outlet stream. Okay. The first thing here is to tell him how many trays. Now it's 10 trays, but in my example it's 12. So I'll change it. Okay, I'll change the number of stages from 10 to 12. Now the inlet stream will be stream number 1. So I'll select it from the drop down menu. Now you see the stream 1 is now connected to the distillation tower. Okay. Now stream 1 is entering the tower from the 6th tray. So you can change the inlet stage from here. You can change it from here. You can select 5, 4, 3, 9, 10. Now I leave it on 6 because he's saying here that the feed stream is entering the tower from the 6th tray. Okay. Now there is a condenser. He's asking me if it is total condenser or partial condenser or full reflux condenser. In this example, what he is saying, here it's a full reflux condenser. You can see here from the workbook, he's saying that the column with 12 trays and a full reflux condenser. What it means, full reflux condenser? It means that all the liquid condensed from the condenser will be returned back to the column as a reflux. Okay? All the liquid condensed here will be returned back to the column. Okay? That's what reflux, full reflux means. Okay? All the liquid coming out from the condenser, okay, will be transferred back or will be returned back to the column as a reflux. And here, total condenser means that all the vapor coming out from the column will be condensed. Or if I select, someone is asking now about what's the total condenser. Total condenser means that all the vapor coming out from the tower will be condensed. Okay? Partial it means that not all the vapor will be condensed, some will be condensed and the rest will be still in vapor. But now here I have a full reflux condenser. It means that there is no liquid product. It will be full reflux here. There is no liquid product. All the liquid, I return it back to the column. But there is an overhead product stream, but it will be, of course, in vapor. So I'll give it any name, such as overhead. I can give it any name. Now we will create a stream named overhead. And I'll do the same with the bottom. I'll give it any name, bottom. Okay. Now I have an inlet stream and overhead stream and the bottom stream. As you see here, there is a condenser and a reboiler. So I'll give any name to the condenser energy stream and the reboiler energy stream. For the condenser, okay, we can use Q1. And for the reboiler, I'll use Q2. Okay, give it any name. If you have a side draw streams, for example, if you have a product coming out from the fifth tray, so you will give him any name and tell him that the draw stage will be the fifth one. Okay, but now I have only top and bottom products. I have any side draws. After completing all these connections, the next bottom will become active. You see here, it was not active, but after completing all the connections required, now it's active. So I'll click next. Now I am in the page 2 of 5. It's about reboiler configuration. It's about reboiler configuration. Okay. Here you can see that there is reboiler type selection. Reboiler type selection. Now the default option is regular HYSYS reboiler. Okay. I need to ask you first, what are the types of reboilers in the distillation tower? What are the types of the reboilers in the distillation tower? Okay, thermosiphon reboiler, right? And the other one? There is two main types for the distillation tower reboilers. Yes, you are right. It's a kettle type. There is kettle reboiler and thermosiphon reboiler. These are the two main types for the reboiler, kettle and thermosiphon. Okay. Yes, fired heater can also be used, of course, and it will be the third one. But as I told you, there is two main, okay, two main types of reboilers. I'll open a presentation for you. Okay. You are seeing now this slide about distillation column. Okay. You are seeing now this yellow yellow distillation column. Okay. Okay. Now, when the feed enters the tower, it enters to the flash zone. Okay. The vapor will go upwards and the liquid will go downwards. Okay. The liquid mainly contains the heaviest components. Okay. I'll share this slide after finishing this session. Okay. I'll share the whole presentation. Okay. After finishing this session. Okay. Okay. Maybe I can use the paint. Okay. Okay. You see here. Now, when the fluid. Okay, I'll zoom out. Okay. Now it's clear. There is no custom zone. Okay. No problem. Now, when the fluid enters the column, this zone, okay, this feed here, okay, this zone called the flash zone. The vapor coming upward and the liquid will go downward. Okay. The liquid mainly contains the heavier or the heaviest components, right? Okay. There is light and heavy. In the bottom, it will be mainly the heavy. Okay. But it contains a small percent of the light components. So I'll send this liquid to the reboiler. What happens in the reboiler? There is partial vaporization. There is partial vaporization. Heat is added to the bottom liquid. Okay. Heat is added to the bottom liquid by any heating medium like steam or hot oil. Okay. And then this heat will vaporize only the lighter components. Okay. This heat will be added to only make the light components in the vapor phase. So I can separate it and return it back to the column. Okay. And the heaviest component will be heated but still liquid. So I'll separate it as a liquid final product. So here we are doing partial vaporization for only the lighter components. Okay, we are controlling the heating steam or heating hot oil or any heating medium to achieve the vaporization temperature for or the boiling point for the only lighter components. Okay, so the lighter components will vaporize and then separated and I'll then return it back to the column, okay? And the liquid or the heavier or the heaviest products will still liquid, so I can separate it as a final product, okay? That's why the reboiler stage is a distillation stage with me, okay? It's clear for you? Okay. Now, as we said, that there is two operations here. There is first heat transfer, okay? Heat transfer by adding a heat to the liquid product, a liquid coming from the bottom of the tower. And second operation is separation. Okay? Now there is a heat transfer and separation. Heat transfer by adding heat to the liquid coming from the top of the tower, okay, to vaporize the light. And then I need to vaporize, I need to separate the vapor from the liquid. So it will be another stage, it's separation stage, okay? The difference between the thermosiphon reboiler and the kettle reboiler, that in the kettle reboiler, the two, both heat transfer and separation occurs. Both heat transfer and separation occurs in the kettle reboiler. But in the thermosiphon reboiler, only heat transfer happens. Okay? I'll show you something now. You see here? This is the kettle reboiler. Okay, as I told you, I'll share it after finishing the this session. Okay? Okay. Now, you see, this is the kettle reboiler. The liquid coming from the tower bottom or the bottom of the tower is going here to the shell side of the shell and tube heat exchanger. Okay? This is the shell and tube heat exchanger. Okay? But this shell is larger than the tube. You see here, this shell is containing this extra volume. Okay? Now the liquid is coming here. It will fill this section. This section, there is a indirect contact with the steam coming to the tube side heat exchanger. Okay? Here, it will be the heat transfer in this area. The heat transfer will happen in this area between the liquid coming from the tower bottom and the steam coming in the tubes side. Okay? This extra volume will allow the separation of the lighter components as a vapor from the top, and the remaining liquid will be separated from this section. Okay? After getting down here, you see here, there is a weir. Okay, there is a weir. After this weir, this liquid can be separated as a final product. Okay? Now this the idea of kettle reboiler. You see this picture. This is a kettle reboiler in industry. The tube bundle goes, okay, and it will heat the fluid in the shell. Okay, the hot stream will be in the shell, tube side, and the cold stream will be the shell in the shell side. You see this tube bundle? It will contain the steam, and this shell will be the fluid that I need to separate vapor from liquid. Okay. The other type, the thermosiphon reboiler, you can see here, it's a usual or a traditional shell and tube heat exchanger. There is no extra volume in the shell. Okay. So here only what happens is heat transfer only. You see here, the liquid is coming down from the top bottom of the tower, and then it will go to the heat exchanger, and then it will return back to the tower as a liquid and vapor mixture. Okay, not only vapor like kettle reboiler, because in this thermosiphon reboiler there is no separation. So I'll use the bottom of the distillation tower as a separator. I'll separate in the bottom. Here I can separate liquid from vapor. It's clear now? Okay. Now the main difference between kettle reboiler and this thermosiphon reboiler, that the thermosiphon reboiler allows only the heat transfer to be done. But for the kettle reboiler, both heat transfer and separation can be done in one equipment, okay, without need to the separator. As you see, this a normal shell and tube heat exchanger, okay, like thermosiphon one. There is no extra volume for separation. The shell is adjusted to the tube. This is a tube bundle, okay. So I need another equipment to separate. There is the third type of the reboiler is a fired reboiler. Here, it will not be a heat exchanger, it will be a heater or a fired heater. It's used mainly when I need extra duty or I need higher duty, okay, to accomplish this separation or to accomplish this partial vaporization. So this fired reboiler is here to achieve higher temperature than I can achieve when using a normal heat exchanger. Okay? But now in HYSYS, I return back to the HYSYS. Here, he's asking me about the reboiler type selection. Here, there are three options: regular HYSYS boiler, and heater option, and heat exchanger option. Regular HYSYS boiler is for the kettle reboiler. Regular HYSYS boiler is the kettle reboiler. And for heater and heat exchanger, heater heat exchanger, it will be
Welcome to any meeting. The meeting is in listen-only mode, and only meeting presenters can be heard.
For example, this or this, you see here, the regular HYSYS boiler option will disappear. You see, when you select any option from them, the regular HYSYS boiler will disappear. Okay? It depends on the design of your distillation tower. HYSYS is now allowing you to control or to select the configuration, the suitable configuration for your reboiler. Okay? So now I'll use regular HYSYS reboiler. So there will be no effect for this selection. Okay? I'll go next now. Now the third page. It's a pressure profile page. The first page was connections page, where I enter the number of trays and give it names to the streams. Okay, and second page was the reboiler configuration page, and this is the third one. It's a pressure profile page. Okay, now I have the condenser pressure and reboiler pressure. The condenser pressure, it was 248, and the reboiler, it was 252. So I'll write here 248 psi, and for the boiler pressure, it's 252 psi. If I have the pressure drop inside the condenser or the reboiler, I write it here, or leave it 0. Okay, or leave it 0, but not leave it blank. Okay, I'll go to the fourth page by clicking next. Okay, now he's asking me about the temperatures. Okay, you see the next bottom is active because this window is optional. Okay, I can enter a temperature estimate for the condenser or top stage or the boiler, or leave it blank. In both cases, the HYSYS will calculate the temperature profile for the tower. But if I give him some guidance for the temperature and the pressure for the condenser and the reboiler, it will only help him to solve the column faster, to minimize the iterations. So if I have any idea about the temperature of the condenser or the temperature of the boiler, I can write it here, and the column will solve the HYSYS will solve the column faster with minimum number of iterations required. Okay, for example, if I give him the temperature, it will take maybe 2 iterations to run, or if I leave it blank, it may take 10 iterations to run the towers. Okay, so it's optional. I'll leave it, and I'll click next. Now he is asking about the specifications. What he means by specifications? Now he is asking about the product specifications, of course. Okay. Now for the preliminary design specification, he's saying here that it requires a reflux ratio of 6.06 and a vapor overhead rate is 226 pound-mole per hour. Okay, it's a preliminary design specification. So I write it now and then I'll change it to another specifications. Okay, the reflux ratio is 6.06 and the vapor rate is 226 pound-mole per hour. Okay. In another cases, maybe you have to calculate this reflux ratio or vapor rate. Okay. In another case, it may be required to calculate this reflux ratio and vapor rate. So there will be another specifications you will give to the HYSYS to calculate the tower and then calculate the reflux ratio and vapor rate. Okay. Now we need two specifications. So I give him the reflux ratio and vapor rate, and it will not be the, always I'll give him this data. Maybe I'll change it after that. Okay, it depends on the specifications of the products I need. Mainly, the specifications are the purity, not the reflux ratio and the vapor rate. Right? For the distillation tower, mainly I need to make this distillation column to achieve purity, not to achieve reflux ratio or vapor rate. So in this example only, I write the reflux ratio and vapor rate, and maybe in other example, I'll just click done without entering any data here, and I'll add the other specifications from another window. So you see here, done. It was active before I entered any value. Okay, it was active before. So if it's not your required specification, you can leave it blank and add another specification from different place. I'll show you where we can add this data. Okay, but for this example, I have the reflux ratio and vapor rate, and I need the tower to achieve this reflux ratio and vapor rate by calculating the other parameters. Okay, now I will click done. Now I'll click done. Now this window is similar to the windows that we used to run before. You remember that when we are adding the column, the compressor and the cooler and the separator from the previous example, it's similar to the window that we are used to deal with. There is a design worksheet, performance. Okay. Okay. Now the column is giving me a message. It's unconverged. Unconverged means not solved. Okay. So I'll click run. I'll click run bottom to converge it or to solve the column. Now it's converged. You see here? Converged means solve it. Okay? I can go to the performance tab from the top. You can go to the performance and see the results. Performance tab is a common tab in each in any equipment. You will find this tab. It contains a summary of the results. Okay. The first thing here, you can find the feeds and the product stream. You can find the composition for each stream here. Okay. You can see it as a composition or flow or recovery. Okay. You can go also to the column profiles. See from the left hand side menu, you can see the column profiles. Here you can find the temperature and the pressure on each tray, and the net liquid and the net vapor also for each tray. Okay. And you can go to the condenser reboiler from the left hand side menu and see the duty for the condenser, duty for the reboiler. Okay. And the reflux rate and the outlet flow rate. And there is another important thing that you can see any plot you need. You can go to the plots. You can go to the plots. Again, from the left hand side menu, you'll find plots. You can view a graph for the temperature profile or pressure profile or the composition. Here you can select the composition. You can see the composition on each tray. Okay, you can select here the composition from the plots under the performance tab. You can select composition and click view graph. Here you can find the composition on each tray. This the tray number 4, tray number 5, tray number 6, tray number 7, tray number 8. You can find the composition of each tray here. And there is a legend. There is a legend above. Ethane is a red one, and normal butane is a blue curve. You can check here. You can change the components by clicking on the properties and check on the components you need to view only. You can check on the components you need to view only. Okay? Or click or check all from the properties here. Okay? Now I'll close this window. Okay. Now if he's saying solve here instead of converged, if he's saying solving instead of converged, it means that you are asking him to run the column under specifications that it's impossible to achieve. Okay? When he's giving you, instead of converged, he's giving solving, yellow bar, and saying solving, it means that you are asking him to run the column, okay, with impossible specifications to achieve. For example, if the amount of the propane entering the tower is 100 pound mole per hour, if the amount of the propane entering the tower is 100 pound mole per hour for the propane only, okay, and you are asking him to run the column to achieve the propane on the overhead stream to be 200 pound mole per hour. So it will not solve, of course, because the feed contains only 100 pound mole of propane, and you are asking him to achieve 200 pound mole of propane in the overhead stream, so it will not solve. So check your data. Okay, check your data or check your values. Okay, there is of course you will find some errors. Okay. Now we'll go to the second part in this example. He's asking me about changing the design specifications. He's asking me to change the design specification. Okay. Subsequently, the design is modified to ensure propane overhead flow of 191 pound mole per hour and normal butane bottom flow of 365 pound mole per hour. Okay. So I'll give him another two specifications instead of the reflux ratio and the vapor overhead product rate. It's clear? Now I'll give him another two specifications to run the column instead of the previous two specifications, the reflux ratio and the vapor overhead rate. Okay? I can change or add or delete this from the design monitor. From the design, I'll go to monitor. Okay? You can see here that the column now is running with these two specifications, reflux ratio and vent rate. Of course, because there is a check on the active cell, there is a check in front of the reflux ratio, and there is another check in front of the vent rate of the vapor rate. Okay? So it means that these values, it was unknown, and I made it known for the HYSYS to calculate the other variables. Okay? That's why you are seeing here that the degree of freedom is 0. Degree of freedom means that the number of unknown variables minus the number of equations or constraints, it should always be 0 to solve. Okay? To solve any case, the number of unknown variables should equal to the number of equations. So I give him two known variables to achieve the degree of freedom 0. Now I'll give him another two specification instead of these two. So I'll remove the check from the reflux ratio and vent rate. You see here, the degree of freedom now is 2. Degrees of freedom now are 2. What it means? It means that there is two unknown variables needs to be known to run this column. There is two unknown variables needs to be known to the column to be run. Okay? Now I'll give him new two new specifications or two new variables. I'll give him that I need the proper head flow 191, and another specification will be for the normal butane flow will be 365. Okay, so I'll click add spec. I'll click on the bottom add spec. Now what I have a column component flow. I have a flow rate for one component. If I have its fraction, like if I have a purity of 95% or 99%, so I will select column component fraction. But now I have column component flow, not fraction. So I'll select column component flow and click add spec. Okay. I'll add first the propane flow. The propane comes out from the top stream or the overhead stream. So I'll select the overhead stream. I'll select the overhead stream from the draw. And I have the value with the molar basis because he's saying here that it's 191 pound mole. So it's a molar basis. Okay, and then I write the specific value. It will be 191 pound mole per hour. It will be 191 pound mole per hour. Again, 191 pound mole per hour. Okay. For which component? For propane. Now, the meaning of this window is that I need the propane flow rate to be 191 pound mole per hour from the top stream. Okay. Now the propane will come out from the overhead stream with a quantity of 191 pound mole per hour. Okay.